Routing is forwarding a packet to another network or subnet. A routing table lookup yields the longest prefix match for the destination. Routers are responsible for selecting the best path to each destination network. For example, if the destination is 10.1.1.1 and there is a route for 10.1.1.0/24 and 10.1.0.0/16, the route for 10.1.1.0/24 will be used. The best path specifies the outgoing, also called the egress, interface for the packet as well as the destination. Routing information is stored in the routing table in random access memory, RAM. Routers add routes to their routing tables from three sources. The first source is connected routes, in other words, the subnet used by an interface of the local router. The next source is static routes. These are configured. The third source is routes learned by using dynamic routing protocols. Only connected networks are known if routers are not configured. Let us look at a topology and routing table to learn connected networks. Look at the output of the show IP route command. This command displays the routing table of the router. Two classful networks can be seen in the routing table, the 25.0.0.0/30 and the 10.0.0.0/24 network. The routing table is organized by classful network even if variable length subnet mask, VLSM, is used. There are three routes in the routing table. The first route, 25.25.25.0, is directly connected to Fast Ethernet 10. Because 25.25.25.0 does not have a different prefix length specified, it uses the prefix length of the classful network. So its prefix length is /30. The C to the left of the route shows that it is a directly connected network and is directly connected in the entry. The interface is the outgoing interface to get to a destination that is in the 25.25.25.0/30 subnet. In this case, the outgoing interface is FA10. Now we have two routes under the 10 network. These are 10.1.13.0/24, which has an outgoing interface of FA00, and 10.1.23.0/24, which has an outgoing interface of FA01. Note there is no route to the network 10.1.12.0/24 in the routing table. Without static or dynamic routing, RTR3 does not know how to get to a destination in that network. Let us discuss next hop, a routing term, in the next slide. The next hop is a term that refers to the next closest router encountered when the packet leaves the egress interface. It is the next possible destination for a data packet. For example, for RTR3 in the previous slide, the next hop out for the FA00 interface was RTR1. The next hop out for the FA01 interface was RTR2. The next hop, in this case RTR1 and RTR2, must also have a route in its routing table to the destination, or the packet will be dropped. This is true down the line. All routers between the source and the destination must have routes to the destination. Let us understand how a route will be in the routing table in the following slide. A route will be in the routing table only if its interface is active. If the interface is not up and up, no routes involving that interface as next hop will be listed in the routing table. In the topology on the previous slide, if RTR3's F10 interface fails, or it is administratively down using the shutdown command, then 25.0.0.0/8 network can no longer be seen in the routing table. In the next slide, let us understand how to configure routes that are to be entered in the routing table. In configuration mode, enter IP route, then network and network mask. You have a choice of interface or next hop IP address. Finally, administrative distance AD can be configured, although this is optional. If you choose to specify interface, configure the outgoing interface on the local router. The next hop IP address is the interface address on the next router. In general, for serial point-to-point interfaces, use interface. For Ethernet interfaces, use next hop IP address. Look at the two examples on the slide. Let us discuss floating static routes in the next slide. Floating static routes provide a backup route in case the preferred route is no longer available. If a static route is configured with an administrative distance greater than the routing protocol AD, that route will be used as a backup route if the dynamic route fails. For example, if there is already a route learned by a routing protocol for 10.1.0.0/16, a backup route can be configured with the command shown on the slide. This route will not be used unless the preferred route fails because the AD of 220 is greater than the AD of any of the routing protocols. In the next slide, let us focus on default routes. A default route is the route taken if there is no more specific route for a destination in the routing table. It is also called a gateway of last resort for the router. On the slide, it can be seen in the routing table as gateway of last resort is not set. A default route can be a static route or it can be determined by dynamic routing protocols. Let us look at static default routes only. This slide shows the routing table for RTR3 in the topology after adding the static routes. Note that the static route in the routing table for RTR3 is denoted with an S on the left. Instead of an interface, as the other routes show, this route says via 10.1.13.1. This is because 10.1.13.1 is configured as the next hop for that route. In the next slide, let us discuss how to configure default routes. A static route is defined on RTR3 with the command shown on the slide. Similar static routes are defined on RTR1 and RTR2. Take some time to review the routing table. There are two static routes in the routing table. The static route with an asterisk, S asterisk, is the candidate default route. Note that a default route in the routing table appears as 0.0.0.0/0. The routing table now displays gateway of last resort is 0.0.0.0 to network 0.0.0.0. Let us look at how this works. Suppose RTR3 has an IP packet with a destination IP address of 10.1.12.1. It performs a routing table lookup and uses the 10.1.12.0/24 route. What if the destination IP address is 8.8.8.8? There are no routes in the routing table that include this destination. Because the routing table does not have a more specific route, the packet will be forwarded out FA10, the interface specified for 0.0.0.0/0, the default route. There is another method to configure a default route, with the IP default network command. Let us focus on this command in the next slide. In configuration mode, enter IP default network, then a classful network. Now each downstream router treats this router's route for the classful network as a default route. In the topology, the default route would be configured only on RTR3 with the command shown on the slide. The network 25.0.0.0 is used because the command requires a classful network. The classful network with 25 in the first quartet is a Class A network, so it is /8. Let us look at the routing table after configuring this command in the next slide. There are two asterisks, one on the classful network containing the subnet. The other appears as S asterisk, in other words, a static route. The candidate default route is now 25.0.0.0/8, and the gateway of last resort refers to this route. Take some time to review this routing table and practice configuring default routes using both the IP route and the IP default network commands. Let us discuss dynamic routing in the next slide. In dynamic routing, routers learn about routes from neighboring routers. The routers communicate with each other using the same routing protocol. They update each other with routing information. If more than one possible route exists to reach one subnet, dynamic routing protocols choose the best route based on a metric. This route or routes are entered into the routing table. If a change in the network happens, routers update each other on the change. The advantage of dynamic routing is that routers learn the routes. They do not have to be manually configured. There is a difference between routing protocols and routed protocols. Let us discuss this in the next slide. Routing protocols are used to implement dynamic routing. Examples are Routing Information Protocol, RIP, Enhanced Interior Gateway Routing Protocol, EIGRP, Open Shortest Path First, OSPF, and Border Gateway Protocol, BGP. Routed protocols, also called routable, are Layer 3 protocols that transfer data from one host to another across a router. Examples are IPv4 and IPv6. Let us look at some more routing terminology in the following slide. An autonomous system, AS, is a network under common administrative control, such as the cisco.com domain. All routers sharing the same routing table information are in the same AS. Routing protocols are divided into two classes. An Interior Gateway Protocol, IGP, is a routing protocol used within an autonomous system. An Exterior Gateway Protocol, EGP, is a routing protocol that routes between autonomous systems. Let us discuss the other way to categorize routing protocols in the next slide. There are three major categories of IGPs. One is Bellman-Ford, named after the algorithm used by the protocols, such as distance vector protocols that use direction, also called vector, and the distance to a destination. Second category is Balanced Hybrid, also called Enhanced Distance Vector. There is only one routing protocol in this category, EIGRP, which uses more than vector and distance to create the routing table. Link state protocols are the last category. They use the shortest path first algorithm to create a view of the entire network topology. Let us discuss how routing protocols determine the best path in the next slide. Routing protocols use metrics to determine the best path. This allows the protocols to compare paths and to deem one path more expensive than another does. Different routing protocols use different metrics. RIP uses hop count. EIGRP uses a calculated value that takes into account bandwidth, delay, and optionally, load and reliability. OSPF uses a metric called cost, assigned based on bandwidth. The route with the lowest metric will be entered into the routing table. If there is a tie, the administrative distance is considered. Administrative distance is a measure of the trustworthiness of a routing source. Let us discuss this in the next slide. Each routing source is assigned a number from 0 to 255. A value of 0 means trustworthy. 255 means the route will not be entered in the routing table. Given multiple routes to the same network, the route with the lowest administrative distance is preferred. The destination networks must be identical for administrative distance to be taken into consideration. For example, 10.1.1.0/24 is not the same as 10.0.0.0/8. Here, the longest prefix match rules. So the route taken will be the route for 10.1.1.0/24, and administrative distance is not considered. Let us look at some common administrative distances. Each routing source is assigned a number from 0 to 255. That rates how trustworthy it is. The table on the slide shows the default administrative distance for routing protocols. Take some time to study it. We have discussed routing protocols in general, but how internally does a router process the packets for forwarding? Let us discuss this in the next slide. Cisco devices use three methods to forward packets. Let us start with the slowest method, process switching. In this method, the CPU processes each packet separately. It does not recognize any similarity in packets, for example, source or destination address. Fast switching is faster than process switching. It uses a cache to store the Layer 2 header and outgoing interface for the most recently used destinations. When a packet going to a cached destination is encountered, the cache information is used. Of course, the first packet in any flow still requires process switching. The fastest packet forwarding is accomplished by Cisco Express Forwarding, CEF. This is the default packet forwarding method used on the latest Cisco routers. It builds efficient tables that are accessed quickly. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.